here? Okay. Showtime. Sort of. So there's not very many of us here today. And so I don't want to, I had kind of planned out to do a couple of kind of tricky review questions. So what I'm going to do instead is I'm going to post them on Moodle, and then you're going to hand it in to me for completion marks. Okay. The reason I'm not doing written assignments this term is because it just got to be too much with all the marking. And so you're just getting Moodle assignments, but it's good to get the written practice, right? Because tests are written, of course, and the final's written. And so it's good to get that practice, but also because it was a long time ago that we covered this stuff, right? So it's probably not that fresh, maybe. It's been a while. But also because there's not very many of us here, I don't want to be here all night just going through review problems. I'll just kind of give them to you guys, let you work through them, hand them in for completion marks next Monday, and that'll be good. Okay, so I'll post those on Moodle. It'll just count as a freebie assignment, just like the practice tests. But yeah.
Could we do one of them just for the exercise, just as a review?
Let's do it. Yeah. I actually have one that I wanted to do. I'm looking at these numbers, they're the same. I find that happens a lot. Okay, so let's do this one, and then maybe what I'll do is I'll just give you the practice problem. I don't know, I'm still figuring it out. It's tricky. Let's start with some quick review. So we've got review. I changed the thickness of my pencil there. So for review, we've been talking about simple interest. Right, so simple interest problems, they're in chapter 4. And we've been using the formula, the future value is the present value times 1 plus RT. And we've solved problems for the future value, of course. For future value, we've solved problems for P, we've solved problems for R, and we've solved problems for T. And so we've solved all these problems. We learned how to calculate days between dates on our calculators, right? So days between dates. Days between dates on our calculators. We talked about, we started using timelines to try to figure out the information that we're given, right? So mapping problems using timelines. Mapping problems using timelines. And then last day where we ended was we talked about, okay, well, what if we have these unknown payment amounts that we have to solve for? So unknown payment amounts. Yeah, we're just going to go through the problems together. So you don't have to hand anything in. we're just going to do them. So some review examples. I've stolen from the textbook, but I can't remember where. So I'm just going to steal here. So the first example is going to be just kind of calculating some values, comparing the values of two payment schemes, which we haven't done before, but we've done them individually, and so now we can put them together and compare the two. So Mr. and Mrs. Carter are considering two offers on a building lot they own in a nearby town. Great. So the first offer is a total of $49,000 with $10,000 down, so a down payment of $10,000, and then the remaining, so the balance, which is the remaining $39,000, is going to be paid in 6 months from now. Okay. The second offer is a total of $50,000. Okay. $50,000 with $10,000 down again, right? But then the remaining $40,000 paid in 1 year. Right? And so these options have some value today, right? So you want to compare the values of these two offers today, right? Which one is better? Okay. And so, because face value, right? We look at this and say 49,000 and 50,000, 50,000 is better, right? But because we're getting 40,000 of that in a year from now and not in 6 months, that could make a difference, right? Because when we discount it, right, calculate the present value of that 40,000, it might be less than the present value of 39,000 6 months from now. So that's what we're going to figure out. Which offer has the greater economic value if money can earn 5%? 5% simple interest, of course. That's all we know how to deal with. Until today, we'll introduce compound interest. And then I've got use today as the focal date. Okay. Meaning we're going to bring all our payments to today. Okay. So we're going to start by mapping these out with timelines, right? With all the information that we have. And because I'm going to be comparing these two offers, I'm going to use the same timeline, right? Even though the first offer has a payment today and one at 6 months, and the second offer has a payment today and then one a year from now, right? Just so I can look at how they compare, I'm going to make the same timeline for each of them. Okay? And so what I'm going to do is I'm going to have offer number 1 looks like this. So when we draw timelines, we just kind of stretch across the page. We want as much space as we can get. And then we've got today as a jumping off point. And offer number 1 has a payment at 6 months. But then because offer number 2 has a payment at 1 year, I'm going to put that on here as well. Oops, 1 year. You don't have to. It's just a way for me to look at things and see how they compare. So remember when you're drawing your timelines, right? You're going to draw your timeline and then all the dates up above and the dollar amounts down below. And so today, you're going to get a payment of $10,000. And then in 6 months, you get the remaining 39,000, right? Because the total is 49,000. And so here, it's not really clear. And the balance, the remaining 39,000 is what that means. We're using today as the focal date. meaning we're going to draw any payments from out here, we're going to draw them back to today, right? To see what 39,000 6 months from now is worth today. And so to indicate that, I'm going to draw an arrow and say, okay, well, here I'm going to calculate P1. Right. 10,000 plus P1 is the total value of offer number 1. Total value of offer number 1. So let's find P1, right? Then we're going to do the same thing for offer number 2, right? And then we can compare the total values of the two. Right? So if we have to find P1, well, there's a couple of things that we have to put on our timeline, right? First thing is we're going to put the time on the arrow. The time here, the distance of the arrow is 6 months, right? So 6 out of 12 because time is always in years. And so 6 divided by 12, and the rate is 0.05. I'm just going to jot it down somewhere so I have it. So now, I'm going to find P1. I know that the future value is P times 1 plus R times T. I can solve for P1, or I can just plug in the values and then solve for P. It doesn't matter. But the future value of this, so when you're trying to determine, right, this is the present value because it's on the left-hand side of the line, I guess. Right. Here's the future value. So the future value is the 39,000. So we've got 39,000 as our future value, is P, which we're trying to find, times 1 plus R, which is 0.05, and then times T, which is 6 over 12. P becomes 39,000 divided by 1.025. I'm cheating because I have them here. So P1 is $38,048.78. And so the idea then is that if you put in this $38,048.78 today and let it sit there for 6 months, it would have grown to 39,000. Right? And so the value today is the 10,000 plus the 38,000. So the total value of offer number 1 is 10,000 plus P1, which is, I'm just going to skip straight to it, 48,048.78. Now we're going to do the same thing with offer number 2, right? To find the total value of offer number 2. Well, any questions before we keep going about those? I know it was a while ago, so that's why we're doing these review examples. So offer number 2, I'll use the same timeline. Right, we've got today, and then I'll put the 6-month mark here, even though that was for offer number 1, and then the 1 year mark So today, same scenario, right? I get paid $10,000 today, and then they're gonna pay me, what was it? 50,000 minus the 10,000, so 40,000 1 year from now. So 40,000, we have to bring that back to P2. I'm going to put the T on this arrow. T, the length of this arrow in years is just 1. And the rate, again, is 0.05. I'll just jot that down. The total, right, of 10,000 plus P2 is the total value of offer number 2. Total value of offer number 2. So, same thing, we're going to find P2. Future value is P times 1 plus R times T. Future value in this case is 40,000. So 40,000 is P times 1 plus R, which is 0.05 times T, which is 1 now. So P is 40,000 divided by 1.05 once you've simplified. So P2, skipping straight to it, is 38,095.24. Pretty good. Okay. So now we can find the total value of offer number 2 is 10,000 plus P2, which is going to be 48,095.24. So face value, right? We were given offers of 49,000 and 50,000, right? But in the end, right? Let me just pull it down here. You have it, so it's just easier if I can just have them here. Oop. Oh, that should say recall. Recall that the total value of offer number 1, these are really close, right? So even though it looked like $1,000 difference, it's not really, right? In fact, the difference is what, 46 is what I have? Not that big. Okay. Therefore, offer number 2 is better by $46.46, right? So not the full $1,000 that at face value it looks like, right? But in fact, just $46.46. What if there's a really fun promotion going on if you pick offer number 1, like a free iPad maybe? Yeah, I'd do it. Looks like it's $1,000 less, but it's not really. They don't do that though, unfortunately. Any questions about that problem? Okay. So there's another question that I wanted to do as a review, because what we ended on was finding these unknown payment amounts, right? So I also wanted to do a review question on that. I tweaked it a little bit though. And I typed it out. Oh, we've decided to buy a car is the question. It doesn't matter. So here, review question number 2. And then when I typed it out, it got nice and big. Oh. Here. I'm just adding, you've decided to buy a car. Oops. To buy a car is what the question said. And then here is everything that I added. So here's a review problem of finding these unknown payment amounts. So you've decided to buy a car. The first payment that you're going to make to the bank, probably, right? You're trying to save for a car, is kind of understood, is going to be made 1 month from today. So you're going to make your first payment to the bank to your savings account 1 month from today. The second payment is going to be double the first payment, right? So whatever you paid in the first payment, second payment, you're going to double it. We don't know what those amounts are, but we can still work with that. And that payment you're going to make 3 months from now. And then you hope to have $13,000 in your account 6 months from now. So you're going to make a payment a month from now, and then 3 months from now, and those payments are going to grow to $13,000 6 months from today. What must your payments be? Assume you can earn a simple interest rate of 5%. 5% again, boring, but whatever. Doesn't matter. So first thing we're going to do is we're going to map this out in a timeline, right? Because there's a lot of information here. And so your timeline, we'll start making the longest line we can. And how we're going to tackle these timelines, right? Especially when we have lots of dates like this, is you're going to first read through the question and just figure out how many dates there are, right? Maybe jot them down on the side somewhere, or maybe in your mind. Okay. All these payment dates are referencing today, right? So we should probably put today on the timeline, right? That's a good place to start. And then the first payment is 1 month from today, so that's 2 dates. And then the second payment is 3 months from today. And then finally, we need these amounts 6 months from today, right? So we've got 4 dates to put on our timeline. Okay? So now that we know that, we can say, okay, well, we have the outside 2, right? Today and 6 months from today. But now I'm just going to put 2 more ticks on there, so I have 4 ticks. And then I'm going to list my dates on top. So today, and then here's one at 1 month from today. Second payment, 3 months from today. Notice that I put them the same distance apart. It doesn't actually matter if they're closer or further apart, because the whole point of the timeline is just to visualize what's going on, right? So you don't have to spend any time thinking, oh, well, 1 month is closer to today than 1 month is from 3 months, right? You can just put them equidistant. It's fine. And then the last one is going to be at 6 months. There's nothing happening today, right? So we don't have to put anything on that date. It's just a reference date. Okay, all this time is passing from today. What we're going to do, if we have these unknown payment amounts, we use X's, right? We use X's to denote, hey, here's a payment amount that I have to solve for. Right? And so what we're going to do is we're making a first payment 1 month from today. So all I'm going to do, I'm just going to write X there. And that's what I'm going to solve for. Okay? The second payment is going to be 2 times the first payment, right? So 2 times X, whatever X is. So at 3 months, you're going to make a payment of 2 times X. Okay. These payments, right? We're only making 2 payments. First payment and then double the first payment at 3 months. Okay, but these are going to contribute. So these are going to sit here, earn interest until at 6 months, we have to have 13,000 in the bank. Right? So these have to add up to 13,000. Okay. Oh. Sorry. So what we're going to do, right, is we're going to draw these arrows, right? This 2x has to grow to some future value 1. And this x has to grow to some future value 2. The only reason that I'm making this one grow to future value 1 and this one grow to future value 2, remember, is because I don't like my arrows to overlap, but it really doesn't matter which one's which, as long as you can keep track of them, right? And so if you don't mind your arrows overlapping, that's fine. Okay. But I always start at the one closest, draw my arrow, and then move out, because it makes for cleaner timelines. So these future values have to add up to 13,000 because that was our goal. So same idea, right? I'm going to put the time on each of these arrows, right? So I can keep track of them. So the length of this first arrow is the distance between 3 months and 6 months, right? So that's 3/12. The distance from 1 month to 6 months is 5 months, so 5/12. And the rate for each of these is 0.05, just like before. Okay. All right. Just looking at this, right? I didn't tell you what to use as a focal date because you have to use 6 months as the focal date, right? Because, because we have to have a total of 13,000 at 6 months, right? And so you have to use this as your focal date. Oh, just pushing buttons all over the place here. So the focal date, even though I didn't tell you, all the arrows have to go to 6 months. So now we have to find future value 1 and future value 2. Future value 1 is P times 1 plus R times T. P for future value 1 is 2x. Right, so even though we have that x in there, we know how to deal with that, right? Because we're going to have these x's, but they're going to add up to 13,000. And that's why that's important. Okay. So we've got 2x times 1 plus r, which is 0.05, times t, which is 3/12. I don't have these pre-made. So we've got 3 divided by 12, I'll start there, times 0.05 plus 1. And then I'm going to multiply that by 2. Bless you. I get 2.025x. That's future value 1. Just do that again. So now for future value 2 is p times 1 plus r times t. P in this case for future value 2 is just x. So now we've got x times 1 plus r, which is 0.05, times t, which was 5/12. 5/12 times 0.05 plus 1 makes 1.020833 repeating times x. I'm going to store that in 1. So now we've got both of these future values as something times x and something times x. And so what we know, we know that future value 1 plus future value 2 has to equal 13,000. Because that's what we established over here. The total of those future values has to be 13,000. That's the whole goal of this. So what we know, moving the 13,000 over to the left-hand side, so I'm free to work on the right-hand side, is that future value 1 plus future value 2, just rewriting it really. Future value 1 was 2.025x plus 1.02833 repeating x. And you don't want to round here. You want to keep all your decimal places because we are talking money, right? So you don't want to round anything. We have these basically 1 and 2, so 2x and 1x, essentially, with some decimals, right? But you can add these, you can combine these like terms, right? Because you got x and x. And so adding these up, so I've got 1.020833 on my screen, so I can just add 2.025 is 3.045833 repeating x. And what we said was 13,000 must equal this value. Now we can solve for x. Again, keeping all your decimal places. I'll store this in 2. I can solve for x and say x is 13,000 divided by 3.045833 repeating. So 13, divided by recall 2 is 4,268.125855. This is a dollar amount, right? So now we have to round it to 2 decimal places. So it's not until you're dealing with a dollar amount that you can go ahead and round it. So 4,268.13, rounding properly. That's your X. Okay. Remember though, that's your payment 1 month from today, 4,200, whatever. Right? 3 months from today, you're going to make double that. Okay. And so therefore, the payment at 1 month is 4,268.13. And the payment, at 3 months is 2 times that. Let's show it here. 2 times, 4,268.13. Which is going to be 8,536.26. So as long as you know the total, you can find these unknown payment amounts, right? And they don't always have to be equal like we saw last day, which I know was a long time ago, but they can be kind of multiples of each other. I wouldn't do anything other than multiples of each other though. Any questions about that? Cool. So, how about we get into some new stuff? I'll just make a note here. End of review. That was all review? Yeah, we had a break. So, we're just gonna start 4.8 because 4.7 is just strategies for solving these problems, which you're welcome to read, but it's basically just talking about how do you build a timeline, all that fun stuff, right? Which we just talk about all the time anyways. So there's nothing to write down. So 4.8 is changing interest rates. So this is kind of a special case scenario where you have the interest rate starts at some value, and then maybe every year it increases, or maybe it decreases, I don't know, right? And how do we deal with calculating future values when that's happening, right? Because so far we only know how to deal with a single interest rate, right, for each timeline. So I'll just show you by example, and then that'll be good. So say interest starts at 5% and increases by 1% every 4 months. So starts at 5% and increases by 1% every 4 months. What is the value? What is the value of a $1,000 investment after 1 year? This gets kind of messy if we have to map it out as a timeline, but we'll give it a go. So we start making our timeline, start point, end point, that's fine. Okay. We'll start today. And we know that the end point is going to be a year from today. And then we'll have tick marks every 4 months, right? So how many tick marks are we going to have? We're going to have one at 4 months, at 8 months, and then at 12 months, which is a year, right? And so there's really only 2 tick marks that we have to add on here. So every 4 months, and then 8 months, the rate is going to change. So what this might look like, and I wouldn't make you do a timeline for this, it's just to show you what's happening, okay, is we would invest our $1,000 and it would sit there for the first 4 months, which has a time of 4 months out of 12 and a rate of 0.05. That was the initial rate. And then at 4 months to 8 months, it's going to sit there for another 4/12 of a year. And the rate is 0.06 now. And then finally, from 8 months to a year, sits there for another 4/12 of a year. That's fine. The rate is 0.07. So I'll just highlight that these are the ones that are changing. So we don't have this continuous rate. When we have this, right, essentially what we would be doing is we would say, okay, well, we'll take this 1,000 and then I'll calculate the amount of interest, I, right, capital I is the amount of interest after 4 months. Put that away. Calculate the amount of interest at 8 months, and then calculate the amount of interest after 1 year. But it's going to be easier to just use the formula on your formula sheet. Right. There's the final one in the simple interest column, right? And so to solve these types of problems, you're going to use this long future value formula. So to solve changing interest rate problems, use the future value is still P, but times 1 plus R1 times T1 plus R2 times T2 plus R3 times T3 plus da da da. Essentially forever, or as many as you need. I go to RMTM on the formula sheet. I'll put this in a box. Can't remember what color I was using for the formula sheet stuff, but it's on your formula sheet. So what we've got here, right, if we just rewrite this as T1R1, right, here's your first phase, right, T2R2, second phase, T3R3, third phase. So I'm just going to put little subscripts on here, T1R1, T2R2, T3R3. Oops. So now we can calculate the future value is P times, in our case, right, we end at T3, R3, right, 3 phases. And this value becomes some future value. So we've got future value is P times 1 plus R1 T1 plus R2 T2 plus R3 T3, and that's it for this question. But it can handle as many rate changes as you need. So if we want to find out what this $1,000 is going to grow into, then the P is 1,000 times 1 plus R1, which is 0.05, times T1, which was 4/12, plus R2, which was 0.06 times 4/12, plus 0.07 times 4/12. You can simplify this as 1,000 times 1 plus 0.18 times 4/12. Treating 4/12, I shouldn't have written it so big. Treating 4/12 as just some variable. So then we have 1,000 times 1.06 is 1,060. So after all these rate changes, every 4 months, we would have $1,060 in a year. Any questions about that? Okay. So as you can probably tell, that's the end of simple interest. Right, on your formula sheet, there's no more formulas, so that means we're done. So we're done simple interest. So what we're going to do now is we're going to move on to compound interest. Compound interest is way more fun, just because it's way more interesting. Okay. So chapter 5 is on compound interest. And of course, section 5.1 is called the basics. Like every first section of every chapter, the basics. So far with simple interest, right, we've deposited some amount and it just grows at some interest rate. Right. Let's just talk about saving money, right? Not loans and stuff. Well, they behave the same way, so we'll just have to talk about one. Okay, so we've made a deposit to the bank. It sits there and it just grows at some interest rate. Okay, that's simple interest. The difference when we have compound interest is that at some compounding frequency, monthly, yearly, daily, whatever, okay, we'll learn how to deal with all of those. The bank is going to check in and say, okay, you know what? I'm going to add the amount of interest that you've earned to the principal amount. And then you're going to earn interest on both the principal and the amount of interest that you've made, right? So you've got this kind of snowball effect, compounding, right? The amount that you're earning interest on. So you're essentially earning interest on your interest. So compound interest in its simplest form is just making interest on our interest as well as our principal. So at some specified frequency, right? So it's not happening all the time, although it can, and I'll show you how that works. But at some interval, every month, let's say, the bank checks in and says, oh, you've made this much in interest. I'm just going to smush it together with your principal. And now you're earning interest on all of that. Okay? So at some specified frequency, the amount of interest earned is compounded I'll just put in brackets added to, just to clarify in case compounded doesn't make sense. Added to the principal amount. So we're going to be talking about the compounding frequency a lot. So the compounding frequency is, well, the frequency at which we're compounding the interest. I don't know how else to say it, but it's the frequency that interest is compounded. And F is what we use to denote it. So it's denoted, I'll just change colors here. Denoted by a lowercase f. So there are some common frequencies that we need to know how many times that is per year usually. And so some of these are going to be obvious, some of them are not as obvious. Okay? And so some common frequencies, we need to memorize. Get your highlighters out. First one's okay, is annually. Oops. Annually, which is once per year. Once a year. And F would be 1. That one's okay. Semi-annually is twice per year, right? So the frequency, the compounding frequency would be 2. So semi-annually twice per year translates to a frequency of 2 times per year. Also not so bad. Quarterly happens a lot in business, especially, right? Quarterly reports, this quarter, that quarter, right? So quarterly is 4 times per year. So your F is 4. It gets a little bit confusing because the length of time in a quarter is 3 months. So that gets a little confusing, right? But 3 months is a quarter, right? And it happens 4 times per year. So as long as when you see quarterly and you think frequency is 4, then you're safe. Right? Monthly, we've been using already, is 12 times per year. So F must be 12. The only one that's kind of tricky is bi-weekly is 26 times per year. So F is 26. And the reason for that is because weekly is 52 times per year. 52 divided by 2 is 26. So weekly is 52 times per year. So F is 52. And so for this course, right, we assume that a year has 52 weeks, 26 bi-weeklies, 12 months, and 365 days. That's what we assume in this course. So daily is 365 times per year. So your F would be 365. Any questions about those? So you need to have all these frequencies memorized, right? Because in the problems, I'll say interest was compounded bi-weekly at a rate of 4%, something like that, right? So then you have to know, okay, bi-weekly, that's a frequency of 26. Right? So moving on. The annual interest rate is still going to be R, right? But what you'll notice is that now that we're compounding at some frequency, right, we're going to have a periodic interest rate as well. So the annual interest rate, which is also called the nominal rate, is still denoted by R, lowercase r. But if you have a look on your formula sheet for compound interest, there are no R's on here, right? But we do have I's. Right? Oh, there's only 2 R's, but we'll talk about those. Okay. So the annual interest rate is still denoted by R, but now we're going to start calculating the periodic interest rate. The periodic interest rate is the interest rate for each compounding period. And it is denoted by a lowercase I. Okay. And on your formula sheet, right, you have I is R divided by F. So I is going to be the annual rate, right? That's the rate that I'm giving you in the problem. I'll say the rate was 4% compounded weekly. So then you would take 0.04 divided by 52, for example, to get your periodic interest rate. How much of that interest are you getting in each of these periods? So for example, oops, although fun to write in pink, kind of probably hard to see. Example, if the nominal rate is 6%, nominal is the annual rate, is 6% compounded quarterly, what is the periodic interest rate? So we're calculating I. I is R divided by F, which in this case is 0.06 divided by 4, which is 0.015. I'll make a note here, right, that the interest rates, like I said, will still be given as the annual rate in the question, but an extra step that you have to do now is to calculate the periodic interest rate, right? Because that's what we're using on your formula sheet is the I, right, not the R. And so so the interest rates will still be given as the annual interest rates, or the nominal interest rate. In questions, but we will need to calculate the periodic interest rate. Any questions about that? So let's get into 5.2. So just like I said, for simple interest, right, for all of these problems, I'm going to introduce the formula that we're going to be using, and then we'll kind of rework it, try to solve for all the things in that formula. So we'll start with present and future values in 5.2, present and future values. So as you can see on your formula sheet, the formula that we're going to use is the future value is the present value times 1 plus I to the power of n. So this is how we're going to deal with compound interest. Bless you. Where FV we're familiar with, right? The future value, and it behaves the same way, right? It's on the right-hand side of the timeline. And so it's the future value. PV, we've just been using P, but for some reason in compound interest, we switched to PV. I think sometimes I slipped up and used PV for simple interest. They're the same, right? And so PV is the present value. And I'll just put in brackets, same as P in simple interest. Oops. So that's the future value and the present value. And then we have 1 plus I. I is the periodic interest rate. I is the periodic interest rate. And just as a side note here, I is R over F. And that's on your formula sheet. So we have to calculate that before we can do any calculations. And then finally, N is the number of compoundings in this. So it's going to take the place of time, right? So instead of time in years, now we talk in terms of how many compoundings do we have to go through to get to this future value. So N is the number of compoundings. And on your formula sheet, you've got N is time times the frequency, right? So you can just calculate N, the number of compoundings, by taking time, which is still in years, and F, which is the compounding frequency, right? Which makes sense, right? If I say, okay, you're compounding weekly for a year, right? How many compoundings were there? There were 52, right? 1 times the frequency of 52. Even for 2 years, I shouldn't have used 52. Maybe something easier like quarterly. For 1 year, we've got 4 quarters. If we go for 2 years, we've got 8 quarters. Right? And so here, where T is still time in years. And also where F is the compounding frequency. So for these compound interest problems, you've got these 2 extra steps that we have to do before we can do any calculations, right? We have to calculate the periodic interest rate, and we also have to find the number of compoundings. Okay? But after that, smooth sailing. Any questions before we do an example? No? Let me just check. I had some notes up here, but I think I covered it. I did. Great. Okay. Let's see if I can find these examples. We're going to do example 174. Example 174, what's the value in 10 years of a $150 deposit at a bank? Not sure why they had to add that part, but okay. Which earns 6.8% compounded quarterly. So even though this is a really kind of simple problem that we maybe don't need a timeline for, right, it's always a good idea to draw a timeline just to map things out. Okay? And so what we've got, start point, end point today, and then we make a deposit of $150. We just let it sit there for 10 years, and we want to know how much do we have at the end of these 10 years. Okay. So what I've got, I've deposited $150, and it's just going to sit there for 10 years and become some future value. And that's the value that we want to find. Instead of T on the arrow, I want to put N now, right? Because N is taking the place of time. Right? And so here, I've got N is time times the frequency. Okay? And just making a note here, if it's compounded quarterly, I'll just make a note that the frequency is 4. Right? And here, R is 0.068. So just like I said, so these questions will give you the annual rate, and then we have to find the periodic interest rate. So R is still 0.068, and F is 4. And so here, between today and 10 years, time is 10. That's fine. 10 times 4. We've got 40 compoundings. So now we've got N is 40. We're also going to jot down that I is R over F, which is 0.068 divided by 4, which is 0.017. Just confirm. It is. Only for aesthetics, I'm going to move this over a little bit, but you don't have to. Doesn't matter. There. Give myself some room. So now we have a present value. We want to find a future value. We have N and we have I. So now we can go ahead and do this calculation. So the future value, remember, is PV times 1 plus I to the power of N. The present value is $150 times 1 plus I, which is 0.017, to the power of N, which is 40. 40 compoundings. If you wanted to, if you don't like to do these calculations outside and you just want to do them in here, as long as you show your work somewhere, right, that's okay. As long as you show that I is 0.068 divided by 4, which is 0.017, you could add a couple of lines here in your calculations instead if you prefer that. Right? Same thing for N. N is time times the frequency. So you could just do that calculation in here if you wanted to. I won't, because I like to do them separate. and then put them into the formula. But I totally understand that sometimes we don't like to do that. So this becomes oh. I just have 294.39 written down. That's good. Because it was actually just a rogue calculation. So I was just hoping that it was for that. Okay. So after 10 years, our $150, it would get compounded every quarter, right? So every 3 months, the amount of interest that you've earned gets added on to the $150, and then you're earning interest on the 150 as well as the interest that you've earned previously, right? And it just keeps compounding, compounding, compounding until you have $294.39. Any questions about that? Okay. What if we had to, so now we've solved for the future value. Of course, next step is solving for the present value. Right? So solve for the present value. I guess I didn't make a note like that up above here. It's just kind of all future value. I'll put it above the example. Solve for future value. There. Now you have little reference points of where we did it. So solving for the present value now, right? In general, we've got the future value is the present value times 1 plus I to the power of n. Solving for the present value, if we had to do it in general, right? The present value is the future value over 1 plus I to the power of n. Just kind of moving things over. Now it's your choice if you want to solve for it in general, and then you can use that formula same as for same as for simple interest, right? Where as long as you've shown me that you know how to derive the formula once, then you can use it. Or if you want to solve for it every time, it doesn't matter to me. Okay. But let's do example 175. As an example. So we're asked to calculate the original principal. Oh yeah. Say when. Just there? No worries. I know I went crazy. So calculate the original principal, so the present value is what it's asking for, of an investment that pays $5,437.52 at maturity. Okay. What this is saying is that the future value is $5,437.52 over a term of 27 months at a nominal rate of 8.5% compounded quarterly. And so we've got a lot of information here. So a term of 27 months, so T is 27 divided by 12. The nominal rate, R, is 0.085. And compounded quarterly, F, is 4. Right. So there's a lot of information that we have to keep track of and know what it all means. So again, even though this is a fairly simple problem, right, we're still going to draw a timeline just to get in the habit of drawing timelines. So we've got a start point and an end point. We'll make this today. And this is 27 months from today. It doesn't matter if it was 27 months ago to today or whatever, 20 months ago to 7 months from today, as long as the distance is 27 months, that's all we're given in the problem. I'm just choosing to say from today to 27 months from now. We're told that the future value at 27 months is 5,437.52. So this is going to map back to some present value. On our arrow, right, we're not putting time anymore, we're putting n, the number of compoundings. N is time times the frequency. Time is 27 over 12, and the frequency is 4, which is 9. So 9 compoundings. And then we have I is R over F, which is R was 0.085 over F, which is 4. So we've got a rate, and a periodic interest rate of 0.02125. So now we have all the information, right? We want to solve for the present value. We know the future value. Yeah, we know the future value. We know N and we know I. Now we can go ahead and solve this problem. So now, oh, I guess you don't have to solve for it in general. I always forget that the formulas are derived for you. The present value formula is on the formula sheet. So I guess you don't have to show it. We can just use it. All right. I'm more old school. I like to just have the one future value formula and then solve for whatever I need. Right? Cut down on your formula sheet. The present value is the future value over 1 plus I to the n. The future value is 5,437.52, all over 1 plus I, which is 0.02125, to the power of n, which is 9. Again, I can do that because I've already shown the calculations elsewhere. Which works out to an even $4,500, 0 pennies. Any questions about that? And I think we're done for today. That's where we were supposed to end, but I was thinking about going a little bit further, but I think we can handle next day's stuff in that class. So no worries. So I'll post a little Moodle quiz for simple interest, so you can have a little practice, but it won't be very long, so not to worry. Okay. Besides that, see you on Wednesday.